Alright, so with the distributive law comes just as a single axiom, and it's the one of the only ones that mixes both operations, addition and multiplication. And it does so in the following way. You have, on the outside you have times, so you have something like this. 2 times 3 plus 5. So the idea here is inside the parentheses you have plus, okay? That's a requirement. And outside the parentheses is being multiplied by something. Okay, so you've got both operations, times here, or addition here, and multiplication here. And what it says is that you don't have to do, by the way, all that stuff that they tell you, all the PEM does, the order of operation, it's a bunch of lies. This proves it, because the PEMDAS would say you got to do the parentheses first, but the distributive law doesn't tell you you got to do parentheses first. It gives you choices. It treats you like a human being, not like an insect. It says, you know what, you have choices. You can either do that or do this 2 times 3 plus 2 times 5. That's what the distributive law says. And the reason for the icon is because you got to take the 2 and you distribute it to that, and you distribute it to that. You distribute it to every single term inside. That's exactly what it says. It says that you can distribute it. And it says you can get with this or you can get with that. You can get with this. It says you got choices. You're a human being. Do it whatever you want. If you like this, fine. If you like that, fine. It gives you choices. The order of operation kills your choices. It treats you with a lot of disrespect. It says you got to do this first and that first and that first. And never really explains the rules. Alright, anyways, don't get me started on that. Don't get me started. Alright, so what does that mean? On that side, looks like 6 plus 10. On this one, this side over here looks like 2 times 8. Of course, both sides is 16. The distributive law says it's not an accident. This will always happen. So we can use generic letters here. It says that if we have A times B plus C, that's the same thing as having A times B plus A times C. Incidentally, you should be able to read it forwards and backwards. Backwards, you would say that AB plus AC. You could say, whoa, it looks like someone distributed an A, so maybe I can undistribute it, and this is A plus C. Right? Completely contrary to the order of operations. You're not multiplying, you're actually factoring and then adding more parentheses. Both of these are excellent ways to see the distributive law. What does it apply to? Well, it applies to all the numbers in our class, all the terms in our class. Let's practice it. So, have you ever heard, okay, so let's do it this way. Suppose you have 5 times 2 plus 1. What does the distributive law say? It says you could distribute, so this would be 5 times 2 plus 5 times 1. This is by the distributive law. Okay? And you could say, well, this is 10 and this is 6. Sorry. That's by times table. And then you could say, well, that's 15 by addition table. Okay? You can always go backwards on these things as well. You might have heard the term before. Here's something else that we can do now that we couldn't do before. You may have heard you should collect like terms. 3x squared plus 5x squared. How do you add x squares? They're not in the addition table because they have variables, but here you can say, whoa, it looks like someone distributed an x squared, so maybe I could do this 3 plus 5 times x squared. That's by distributive law, because if I was to distribute that, by the way, you can distribute on both sides. You would get exactly that idea. That same number. Imagine distributing this and that, you'd get exactly the previous step. So that's the distributive law backwards. The next step is, well, 3 plus 5, I can do that based on the addition table. I could say that's 8x squared addition table. These two have no x's on them, they're just plain numbers. Addition table will work on that. And there you go, we just added like terms. You may have heard it before, you should always add like terms. This is why, it's the distributive law. Okay? Very nice. And there's many more examples. Maybe we can do one more. Suppose you have 3 times 10 plus 5 times 10. One way to do that would be to say, you know what, it looks like someone distributed a 10. So I could factor it out, 3 and a 5 times 10. That's the distributive law. And of course this is 8 times 10. That's the addition table. And of course that's 80. That's the times table. And the first one equals the last one by transitivity property. Nice, huh? That's the distributive law. You get to practice it a lot more on the flashcards. Deep, deep, deep. Super important. Alright, very last two axioms. They come in pairs as the other ones do. We'll get to those next and we'll be good to go.